Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Keynes, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we're very lucky to be joined yet again by Scott Wlaschin. How you doing, Scott?
Hi, thanks for having me on.
Well, thank you so much for taking up your bank holiday. I was saying off air, your bank holiday weekend, your bank holiday Monday, slam bang in the middle of it to do a lovely podcast. But it is raining outside. So how are things going there, man? How you been since the last episode?
Things have been good. I've done a couple of talks. I went to a couple of conferences, and now I'm just back relaxing and just figuring out maybe I'll write another book or something. I haven't decided yet.
Oh, you see, you scratched the itch. I remember the last time we spoke to you. Well, actually, I think it was in February we spoke to you about that, about your recent book, your great book. And it seems you're scratching another itch, to write another one. So the pain has kind of subsided, has it, from like the thoughts, the remembering of it, and now you want to do it again?
Yeah, I think I kind of like writing books. It is painful doing it. The writing is painful, but it's kind of nice that people seem to say nice things about it. It's got good reviews on, it makes me very happy.
I was just wondering, how do you kind of balance kind of the conferences you go with work, with writing, with learning? Because, you've got to think of up ideas to then present, and it must be quite a balance.
It is actually, for me, it's more of a sine wave than a balance. I tend to overdo it. I get a lot of conference invitations, and I kind of go to them all, and then I get exhausted, and so then I kind of cancel, and then I just don't go to any more for like another 6 months, and then I start thinking it might be fun to go, and
that's it.
So it goes back and forth.
Again.
Yeah. So it's the same thing as like anything. You enjoy something. I mean, I get very into something, and then I kind of get not exactly burned out, but it's like, okay, I've had enough of that. And then 6 months later, you come back to it, and you think, oh, that's fun. I should do that again.
But the thing is, with your talks and everything, because they're so in depth and they're so, you always flush your talk out so well, and it's such interesting things you talk about, and we talk about your most recent one today for sure. You do have to invest a lot of time, so it must be you just engross yourself in this topic, and then it can not burn out, but definitely kind of need a little bit of a rest. Yeah,
exactly. It's balance is really important, and that's something I'm working on. I think we all are, but it helps to live. I have to say, I don't live in a big city, and that really helps to have some outdoor activities and some quiet time. So I'm not stressed out, outside of doing stuff, because just being able to walk down the street, and I live right at the sea. That's very nice, and I've got greenery around me. So I think that's very important.
The good yin to the yang of kind of like, dealing with the programming, dealing with being in the office, and then being able to get out and kind of see, wildlife and more important things in some regards.
Exactly. Yeah. Programming is not the most important thing in the world.
You've heard it here first, folks. Shock horror. We all take it for granted.
Yeah. I think that's actually one of the things as you get older. I used to be very, I used to work really hard, and I'd do a lot of overtime. And I'd always believe when people said, "Oh, this project has to be done by the end of next week. It's so critical." And after you've done that, a few thousand times, you realize actually these things are never that critical, and it's not the end of the world if the project doesn't get finished. And you start realizing there's a bigger picture. There's more to life than deadlines and stress.
It loses it's the whole boy who cried wolf thing, isn't it? Because after a certain amount of time, it can't always be that critical, because was it criticaler than the last time, or is it more critical now? It loses it, doesn't it?
Yeah,
the kind of impact.
This kind of stress thing. And in the big picture, you look on when you start looking at a 5-year time scale or 20-year time scale, these things are just not very important in the big scheme of things.
Yeah, you're not going to remember it 5 years down the line, that one, because there'll be undoubtedly another one just, down around the corner, isn't there?
That's right, which is why this thing, I'm just leading into this, that's a good lead into this talk, because it's all about looking at the big picture, and we tend to be so focused on the what's right in front of our face that stepping back and looking at the big picture can be really a useful thing. It helps you set up a context, and it's good. It's a good learning for all of us to look at big picture rather than tiny pictures.
No, absolutely. And you mentioned it there. So your recent talk, 4 languages from 40 years ago, it's just hit the right, the Vimeo. So I was straight on it, listening to it, watching it. I think I've watched it at least 5 times now. I love it. It's absolutely, really, really interesting. Well, it's actually, you say 4 languages, but in quote, really it's 5. It's got a great little twist at the end.
Yes.
But
I won't, it's got I won't reveal the ending.
No, it's a very good ending. Very good ending. Just wondering, so what did actually make you kind of think about this talk? And, it was a really interesting topic to discuss.
Well, because I've been around, as I say, back in the 70s when dinosaurs roamed the earth, and I was actually around then. I know, it's an old joke, but it's still funny. But because people think that in the 70s everyone was a dinosaur, and that there's nothing, that people can learn from that time.
Well, they all think that, I suppose it's like technology, where technology has changed in some regard, where mobile phones back in the day, they were so big, now they've got small. Everything must be, in quotes, better now.
Right.
But, little do they know.
Exactly. And the thing is, I've learned a lot of languages over my career, and I've had a lot of different experience. And I was sort of disappointed to find that some people I talked to actually don't actually have that. And I think in a funny sort of way, learning to program a long time ago, you actually exposed, there weren't these giant kind of dominant monopolies in terms of programming languages. And so people tried out all sorts of different things. And as a result, you tend to have a very wide base of experience. And I think people think today that everything is just Java or C# or Go or JavaScript, whatever it is, and there's a big world out there.
Obviously, you say from the 70s, and you kind of very much focused on that decade. At the beginning, it was really interesting. You spoke, you discussed kind of leading up to that into the 60s, but it seems that the 70s, kind of everything kind of hashed out, and there was a lot of really impactful languages. Why do you think that was?
It's a good question. I think one of the reasons is that people started taking computers. I mean, in earlier times, just even getting a computer to work was a hassle. And, the whole concept of inventing an assembly language to make your life easier. And then Fortran came along, and that was you could even run it on different machines. You didn't have to program in assembly code. That was all kind of amazing that you could just even do that. But when computers became more mainstream, and I think cheap computers started happening in the early 70s, you could actually have a computer in your own, department. You could actually afford a computer for a small team. You didn't have to have a massive mainframe, And I think as a result, a lot more people got interested in computer. It was just more accessible to people, and
then the ideas start flowing, and people get to experiment with it.
And more stuff started being done with software, and rather than designing a piece of hardware that would do a task, people would write software that would do the same task, and that was again a pretty radical concept. And it wasn't just programming language; all sorts of stuff, were invented in the early 70s. Networking and printers, laser printers, and if you look at all the stuff that came out of Xerox PARC, just everything that we think of to do with modern computing was pretty much invented in the 70s, I think.
Which, for a lot of people today, is a shock horror. And, people won't think, functional programming, FP, AI, Prolog, all these kind of logic programming, all these things that we kind of say, even now people are still trying to wrap their heads around and feel that they're kind of, foreign to them. That was all invented, back in the 70s.
Yeah, and people were thinking deep thoughts. I mean, what's interesting is that even though the technology was crude, the people thinking about the potential of technology, were deep thinking some profound thoughts. I mean, Alan Kay was thinking about little tiny tablets that you could carry around with you. I mean, that was very advanced, and now we have them. But Alan Kay was thinking about if you had one, what could you do with it? If you had the internet, if you could have all the computers in the world connected to each other, what kind of thing could you do with that? So people were already thinking about it. Obviously, it made it hard, but like I say, the ideas, the various kinds of concepts of relational databases and logic programming and functional programming, they weren't necessarily performant then, but the people were experimenting with it.
That's it, the germ of the idea, and actually hashing out to a point where they really were thinking how it could be applied was there.
Absolutely, yeah.
So I thought it'd be really interesting actually to take a step back as well. Like I think, we jump into programming languages, we jump into implementation, we jump into the idea of, we're going to use a programming language for this and stuff. And I'm taking my personal time, taking a step back and looking into electronics more, and kind of understanding the fundamentals of electronics, understanding 8-bit computing. So there's a lot of things on YouTube at the moment where you can build like these 8-bit computers just made out of breadboards and stuff, and very fundamental stuff that I overlooked a lot. And especially my learnings from growing up and everything, I kind of never really, because everything was so much more high level, it really didn't, come around. So I'm very much enjoying that at the moment. And I thought it would be really interesting to kind of discuss fundamentally what is a programming language, and why we have these high level languages. What problem are they there to solve?
It's just to solve people being fed up of flipping switches on the. I mean, even assembly languages were something, because originally you would literally flip the switches on the thing to program it, and it's like, well, each combination of switches, let's call that give that a symbol, and then we can interpret those symbols and program the computer that way. With the punch cards and all that stuff. And then, like I say, Fortran came along, and Fortran was a massive improvement. I mean, the idea you could write a program, and not have to worry about which particular computer it was running on. You could compile it for different target operating systems.
So it was all up to the language and the compiler to deal with the translation to that particular architecture.
Yeah, I mean, the idea. I mean, we're always focused on abstraction, and we always like to make things more abstract or more high level in general. And the idea is anything that gets in the way of programming, which is kind of irrelevant, is just it's not relevant. Knowing how, like if I'm adding up a list of numbers, how it actually works in the CPU, I don't actually care as long as I get the right answer. So rather than having a bunch of assembly language instructions in Fortran, I can write a loop and it will just do it for me, And that's let the compiler figure out what the assembly language's instructions are for that. And then of course, languages like Fortran and then, later on C and stuff, I mean, they were very high level at the time, and now they're considered low level because we have even higher abstractions.
I was thinking that's exactly it. I mean, people will go back, I'm going down into C language, and people are like, whoa, that's really low, but that's far from it, far from what actual low level is. And it's funny you say like a loop, now we look even more high level when we think of it as a map or something of that, it's the paradigm shift.
We'd have a function that does a map to do a sum or something rather than having an explicit loop. So the abstractions, and it's just relevant to what your particular thing. I mean, if you're doing hardware, programming in C is pretty high level. If you're doing a business application, then C is probably kind of too low level. So it's all relevant to where you are. It's all context specific,
And that really does lead on to different paradigms, because at the moment, the general, it's very interesting with this idea of a general purpose programming language. And, I think that's one of the things definitely taken away from your talk and stuff, and the different, the plethora of different languages out there. And the more you investigate into languages, the more you realize, well, and also actually, you mentioned it in the talk, what are you going to use, for this particular job? And there's the joke of, the hammers and toolkits, like I'm always going to use a hammer, because that's the general purpose language. It's like, I know PHP, I know Python, I know Ruby, I know Java, I know C#. I'm going to use the same language for the same thing, for each different problem I have. What is then a programming paradigm?
That's a good question. I would say that it's a way of, it's a mental model of solving a problem. I mean, the idea of writing a program is to solve a problem, is to get the computer to do something for you. And, depending on, you have different ways. Thinking about how to solve the problem will give you different solutions. So if you want to, I mean, a very simple example is relational programming versus, imperative programming. If I want to query a bunch of records in a relational model, the model that I have in my head is that the data is stored as a set of relations, and I can, filter on the relations and project on the relations, all that. If I'm thinking of an imperative model, I'm thinking about, well, I need to open a file and loop over all the data structures in the file and extract. The model that the model that you are thinking of, it affects the way you program. Definitely in your head. If you think of things in a certain way, then you're going to program in a certain way. And we are familiar with the imperative model, the classic procedural way. Most of us are also familiar with relational way of thinking. And it's funny, I mean, when sometimes people who aren't familiar with relational databases and they try and program SQL like they're programming Java, and they start the loop in the database. It's like, and that's not how you program SQL. You need to get it's this thing that it changes the way you think about programming.
It's suiting that domain, that problem domain, and mapping, the ideas that you want to, think of it that way, to it that's best suited.
And so it's a way of thinking. It's not necessarily tied to a particular programming language. For example, you can do in C#, you have LINQ, where you can sort of do relational kinds of stuff inside C#. So it's not that the language itself determines which paradigm to use, but understanding what the paradigms even are, using LINQ in C# is a very different way of programming than using the imperative style in C#.
Absolutely. And I think that may be the thing at this time where languages are blurring the lines a lot, aren't they? You don't have very strict languages. And I think it's nice to go back, and it's interesting. I don't know whether you've actually read the book, the 7 Languages in 7 Weeks book, and then the follow-up, the 7 More Languages in 7 Weeks books, those ones that touch upon, a plethora of 7 languages in each book, but they touch upon a plethora of different paradigms, but very fundamental different paradigms, and explain the different ones and, how they're almost to the extremes of each. Whereas now, in the languages, the general purpose in quote languages we use, they blur the lines between solving a lot of different things using a bunch of different paradigms. I can write PHP code in a functional manner, or as you say in LINQ, you can write C# and you can use like relational kind of mappings over things and kind of, this thing and functional as well. So, you also with a bunch of imperative stuff, if you really want, and some OO put in there as well, it's kind of chucking a lot of different ideas in.
Yeah, exactly. I mean, I think for learning a paradigm, it is best to go for a pure a language. So with different paradigms, some languages literally embody the paradigm in the way they are structured. So in SQL, you have no choice but to use relational style, programming, and in kind of basic C, you pretty much have to use imperative stuff. So if you're going to learn to do object-oriented programming, or you're going to learn to do logic programming, it's really good to use a language where the whole paradigm is sort of baked into the language.
You don't get the best of the paradigm, do you, really? Because you're only getting a little piece of it, or it'd be blurred in with others. You don't really see the full potential of that one paradigm if you don't see it, in its entirety, looking at it. Especially for learning, it can just be very confusing to kind of disambiguate which bits are which.
And also you fall back on what you're familiar with. If you're trying to learn functional programming but you're using Java or something, it's kind of hard because you're going to be falling back to immutable state and so on. It's a bit like learning. It's just like learning a foreign language. If you want to learn French or Italian or stuff, it's hard to learn when you're surrounded by English speakers. If you really want to learn, you need to immerse yourself in that culture and not speak any English. And by the time you've done that for 6 months, then you'll be a decent French speaker, or whatever. That's the same kind of thing for learning, say, logic programming. You need to immerse yourself in Prolog or whatever. It's really hard to do it if you're embedded in a language which really doesn't have that as its main design.
Absolutely. And it's funny because in the talk, you have this kind of galaxy brain seal of approval system, which I really like. And, it's kind of these different languages that over time have kind of embodied those particular paradigms and really shaped them. It'd be really interesting maybe to actually, again, go back a little bit further, looking into these paradigms and maybe just kind of having a brief overview of each paradigm, if you don't mind. So it'd be interesting. So what actually then is, I mean, we're all very familiar with it, but like kind of defining what is an imperative procedural programming language or paradigm?
Well, the idea is you. That's a good question. I never actually thought how to define it, but it's a bit like fish in water. We live in it so much that we can't even conceive.
I think that's the problem, isn't it? It blends into everything. It's very statement based.
Things are statements. You have variables and you change the variables using statements, not expressions, and then you can group a bunch of statements into procedures. Named procedures, which you then execute to do something. And that goes all the way back to, to Fortran, Algol, Fortran. I mean, Algol is really, if you look at what Algol looks like, it really looks like it could have been invented yesterday. It's really not that different. And that's 1960. So, I mean, I think in terms of defining it, it is defined by also, I guess it's trying to define by just a higher level version of what the von Neumann computer, the CPU looks like. You have registers, you have you have memory that you can address, you have pointers to these things. You mutate the data at those memory addresses, and in a language like C, that's really, really explicit in the design of the language that it's trying to be just a one layer above the hardware. I mean, ironically, the hardware has completely changed now, and modern CPUs aren't designed that way. They have pipelines and have also the different levels of caches and all that stuff. That's not captured in mainstream programming languages. So, ironically, something like C doesn't actually represent.
There is abstractions underneath it, even still, even more so. And then obviously the next one, which we're all very familiar with, is the object-orientated approach. And it's been, heavily used because of, the ability to be able to abstract kind of these common domain patterns that we have. Problem spaces are mapped very well to an OO approach. And actually really interesting, why then is, because I mean, imperative procedural, that came around, as I say, von Neumann. It's very easy to understand kind of why it would bubble up to that, where you've got these levels of abstraction and eventually you get here and it's like, oh, well, this is a good layer for people to stop and be able to write with and use on a day-to-day basis because they can, compile down to these different, and then obviously with C, that was very influential with Unix and whatnot. But OO, why was OO so popular and has been so popular and remains such a popular paradigm to use?
Well, I think it was the first paradigm to really emphasize two things: encapsulation, first of all, the idea that it was data hiding, that there's things you can't talk to, you can't actually get to the data, you have to go through an interface, public methods we would call them nowadays, to get to the data. And the second thing is that it's behavior based. The idea is that I don't care what the data actually is, I just care about the behavior of the data. So again, it's the API, the public interface, we would say, is the most important part of the application, and the actual implementation is not so important. I mean, it's not what's exposed. So that by having little mini, if you think of a class as a little API, by having these little mini APIs all over your application, then you've got modularity, you've got encapsulation, you've got all these good things. So I think that's why it was very popular. That's why it kind of took off, because it kind of encapsulated. People knew that modularity is important. People knew that working with interfaces and data hiding was important. And so object-oriented programming sort of really represented that very well.
Because it came around from Similar, didn't it? 67.
Yeah, there's two schools. There's the Similar school and there's the Smalltalk school. And the Similar school is, the kind of similar to the Java, the modern sort of typed programming with Java and C# and so on. And then the Smalltalk school was what I would call, real OO programming. This is where it's very controversial, but to me, it really, really is object-oriented programming. I don't think Similar was ever actually called object-oriented programming at the time, but Smalltalk is a very, very different way of thinking about programming. And so people who are used to using mainstream object-oriented programming languages, using Smalltalk is actually a very different experience.
I was going to say, yeah, definitely. I'd say recommend to watch the video and watch your demo with it, playing around with it, and you'll be amazed, even the ifs and the else's and whatnot. And it all just makes sense. It's very simple constructs that just, again, used to the nth degree in a paradigm to emphasize its use. It's interesting because with Java and C# and these languages, they're OO, but they're imperative as well. But they're it's very strange actually, because they're not totally either or. They're a bit of both, aren't they? Like, they don't want to deal with the memory management too much, so they let the garbage collector deal with that, so they don't have to be that low level, and they can have some OO concepts. And obviously now they're doing the functional stuff, and yeah, it's very interesting.
Yeah, I like I say, Smalltalk is pretty mind blowing for many reasons. That there's the OO, the fact that it really is object oriented at every level, the fact that it doesn't have a file system, the fact it has an IDE, a fantastic IDE that was, in the 1980s, which is still but basically what IDEs look like today. It doesn't have control statements. It's just everything about it is really amazing. I have to say, it's one of my favorite all-time favorite languages, and I highly recommend everyone learn it. How useful it is for day-to-day programming is different, but in terms of this galaxy brain, does it help? Does it make your head explode? Then definitely it's up there. Absolutely.
There's a great Alan Purvis has come up with some great one-off lines and stuff, and like it's one of his is a language that doesn't affect the way you think about program is not worth knowing. And it couldn't be any more true, could it? And you mentioned it with the dialects of English. Like I know British English and then I know American English, and that you really want to do things at completely different paradigms, completely shifting and completely changing your way of thinking. There's no point in learning JavaScript and then moving, although with the prototypical inheritance maybe a little bit, but like JavaScript and then going to C#, that the two are too similar to really have any kind of breakthrough aha moments in your brain. It's when you go to say even go SQL to C#, or you go C# and then you go, I'm going to learn F#, or I'm going to learn Prolog or something like that. That really does, kind of allow you to expand, your programming knowledge.
Yes, absolutely. And what's interesting is when people learn a new paradigm, they often go back to their mainstream language that they use for their day job, and they say, learning F# has made me a better C# programmer, or learning Smalltalk has made me a better Java programmer, or whatever it is. It's actually interesting. Like I say, how useful it is. This is not about is it going to look good on your CV or resume. This is all about is it's just going to change the way you think. And especially if you've been programming for a while, it's nice to learn some different stuff. And it's good for your brain.
It really is, because it can get very samey. And the fact that all the languages we really use in a commercial setting and a problem-solving setting today are so samey, it's kind of boring. And it's not liberating, and it's not actually beneficial, because there could be a language out there that is far more suited to the problem space.
Absolutely. And I mean, in my talk, I do a little example of using Prolog, which I think is very underrated, and not just Prolog, but other things like SAT solvers and stuff. They can solve programs. I mean, they can solve really complicated things really easy. I mean, in my talk, I showed how to solve a Sudoku in Prolog in like 10 lines of code.
It's fascinating. That's so amazing, and the way you're able to explain it, and and again mapping that model, it just works so well.
Yeah, so if you're doing anything like that, that is a fantastic tool to use. You don't, trying to do that kind of stuff in Java or would be a pain. It's just use the right tool for the job. Not everything is a hammer,
Absolutely, and that actually then moves on, to logic programming paradigms. So, what is the logic paradigm?
Well, the idea is that everything is a fact. You have facts, and then you have rules which relate facts together, and the cool thing about facts, if I say that, 2 + 2 = 4, you can do it both ways. Prolog has this thing called unification, where if I say, what do you have to add to get 4? And it says, 2 + 2. And then you say, well, what is 2 + 2? And it says 4. It works. There's an equality sign which kind of makes both things, things which are equal to each other are equal to the same thing. It's a classic, goes all the way back to the Greeks. And, once you set up a program this way, you get some very interesting things where you say this thing must be this thing, and other thing must be this thing, and therefore these two other things must be similar. So, like in Sudoku, you say, well, everything, every number in each row has to be different, and every number in each column has to be different, and every number in each block has to be different, and that is it. I mean, that is enough information for it to figure out what the answer is. I mean, you can express things that way. You don't have to tell it how to do it. You just set up what the problem is in terms of various equalities and various constraints.
Absolutely, and it's you mentioned there with the two the SQL and the Prolog actually in your talk, and how they follow a very declarative approach, the what not the how philosophy. I just went, why is that so useful then to just describe the what and not actually care about the how?
Yes, well, so using the relational example, if I want to find all the people who are older than a certain age in SQL, I would, write a SQL query. Find me all the people, select people where age is greater than 50 or whatever. If I was doing this in a low-level language like C, I'd have to open up a file and have to read all the records from the file. And I don't care when I'm programming. I don't care how you do it. I just say, this is what I want to do, and how it actually works behind the scenes is really irrelevant. And obviously, the SQL engines have a lot of complexity in terms of how they interpret that. And even in a high level, even in working in one language, I mean, even if I was working in C#, rather than iterating over a list and adding all the numbers up, if I wanted to create the sum of a list of numbers, I'd probably write a function called sum, which takes a list of numbers. And I don't care whether it adds the numbers up from first to last or adds them up from last to first, or whether it does it in parallel. I don't care how the thing does it. I just care about what the answer is.
That's not my problem I'm trying to solve. That's
exactly.
Your problem. That's really abstractions again, isn't it? To try and hide away things that aren't actually part of the real problem you're trying to solve.
Exactly. So again, this is just standard best practice in terms of designing an API or designing anything, is work at the right level of abstraction and don't concern yourself with things which are irrelevant. And you're wasting your time. And obviously you have to be careful, because there's leaky abstractions where, you've got an abstraction and actually you do have to care how it works behind the scenes. Which makes
it's harder than actually, you're better off sometimes just tearing away the abstraction, because it doesn't actually help towards the end goal.
That's right. But so, on the whole, though, I mean, you just have to be careful. That's just design. How to design something carefully is a tricky problem, and it requires a balance of this and this. But it's to me, this is a focus on design, and I think we all as developers should spend more time thinking about design and less time thinking about coding in terms of what's important. People. One of the side effects of the whole agile thing, unfortunately, has been this thing of let's just start hacking away.
You don't design is the whole problem, isn't it? It's throwing away design phase, full stop.
Yeah, I mean, the big design, people are scared. We don't want to do a big design up front, and it's just a bad word. Design is a bad word. And people have been burned by spending 6 months writing a design document that never gets implemented or what's. Yeah, absolutely. But design is a really important thing. And then, I'm glad to see that sort of design is actually coming back. What's his name? John Oosterhout, who's the Tickle guy, has just got a new book called Philosophy of Software Design. He's been around for a long time too. He's all about thinking. Think before you code. Don't just start coding. Do a bit of thinking. And he's got some very useful tips in his book. Some of them which kind of directly contradict some of the stuff that comes out of some of the agile people. But I've been reading his book, and it's actually, I would recommend it. It's actually very good. It's a lot of it's if you've had a lot of experience, this is kind of absolutely the right way of doing things. Common sense, really.
I think we all get burned, don't we? I think, it's to say, like, you get burnt with the whole idea of designing up front too much, and then you get burnt with the opposite. You kind of go the inverse, and it's completely the same problem where I really should have thought this through before I started, banging away at the keyboard.
Yeah. I just think there's some people, unfortunately, people like to kind of follow some people's, ideas without kind of reflecting on them. And some of the agile people, it's like they say, you must follow these rules. And like anytime someone follows rules blindly, I think you're just asking for trouble. You need to think about it.
There's always a shade of grey. And, there's always pros and cons for using different things. And as you say, rules aren't, really programming isn't rules. It is, a bit of everything. And it's all dependent on the problem you're solving and constraints and everything around it. And what you really need, and what's best for the customer, and I think the whole, this whole idea of startup culture and everything, and the idea is we want to ship something very quick, so we want to be coding, we don't want to be wasting time, and then we'll just chuck it away. Is the philosophy, isn't it? If it doesn't work, or if we do get some money, or we get some success, we can rewrite it. But good design will aid in that being able to separate this in such a way that rewriting certain parts will not affect other parts. And this is really the value. There is value in thinking up front. Can we can we separate these? Have we got any context that we can kind of separate? And
microservices is a good example, because people say, well, the great thing about microservices, they force you to modularize your code. And it's like, well, yeah, but you can modularize your code without having to use microservices.
Exactly. We're all big enough and clever enough to kind of think about code in separate namespaces. But I do think, because it's always that thing of, once it starts, or it's very easy to cross the boundary, people are going to do it. And it as you say, that then what people do is the extreme of that, which is, I will physically not let you do that. By the fact of there being a real, kind of, network barrier between us to do this. But it's sad because, the languages all have namespacing. The languages all have, design, abstractions around this kind of concept of being able to break up code. Why not? Why not use and, take advantage of that?
Absolutely. I mean, yeah, exactly. Languages already have this stuff. It is sad. I mean, there are genuine reasons for microservices, but modularity isn't, is not one of them. You can certainly do modular monoliths, and as the classic saying, I think Simon Brown says, what makes you think you can, if you can't do a modular monolith, what makes you think you can do a modular microservices?
And you've just brought in way more complexity into your code base. You're better off having the big ball of mud that is a monolith than the big ball of mud that is a bunch of microservices.
A distributed ball of mud. I know.
Even worse.
At least with the big ball of mud that's in a monolith, you can refactor it.
Exactly. You can see the code in one place, and you haven't got this, asynchronous action. This weird I think the intentions are there, but maybe it's the execution and kind of, that being more on the fact of, again, but this is funny. This is the design part, because people are not thinking of the design up front, and the fact that they've got these barriers, which are implicit, like explicit microservice barriers, it stops them from being able to hack this design together, as opposed to, in the world of not designing at all, I can just do stuff, whatever I want to do.
And like I say, I think the agile, unfortunately, I think agile as a concept, anything with fast feedback loops is a good idea. Unfortunately, some of the agile dogma about not designing things, and I've seen some really terrible examples of, it's like, you don't have to design it, you just have to make the test pass. It's like that just, I have to say, that makes me really angry. Like,
the testing is all about the idea to test first is to make a good design.
Yeah, exactly.
It's to design good APIs. It's completely going against the philosophies.
I know. It's just, anyway. It's I could rant about that, but that's a whole other thing.
Well, we'll go on to something that's near and dear to your heart. One of the other languages you speak about is ML and functional paradigm. We've spoken a lot about functional, but it would be good maybe for this actual episode, maybe to just discuss, what is then the functional paradigm?
Yeah, so the, ML was actually a language which was designed as part of a theorem proving tool. And it was back in 1972. So that's, that's a long time ago. That's about the same time that C was invented. So anyone who says that functional programming is a new thing and it's like a trendy new thing, it's like, no, it's as old as C at least. So, the idea is with functional programming is that you work with functions, and you have a function has an input and output, and you give an input and it comes out with an output. It's not very different from a procedure in a imperative language. The difference is that because it's sort of stealing from mathematical functions, the data, everything has an output. So you don't have statements, you have expressions, and things tend to be immutable by default because you're trying to emulate mathematical stuff. And once you start programming with functions, all the tools that the way that we build programs is by connecting functions together, by composing functions into bigger functions. And if we want to parameterize something, we parameterize things with a function. And if you want to do sort of a dependency injection, we do that with a function. So everything, you just use functions as the building blocks for everything. Now, that wasn't necessarily, I don't think that was the original idea behind ML. It wasn't, but this is how it's evolved over time. By the time you got to the early 80s, when standard ML was kind of solidified, this is how people were doing stuff. So, the functional programming definitely came out of ML, and a whole bunch of other cool things like union records and stuff came out at the same time. It's just a lot of very cool things came out of ML. That whole branch. ML itself took a while to it was invented in 72, but it didn't really standardize until the 80s, But there's a whole branch of programming languages which are still being used today, F#, OCaml, and so on. And, it's a really, really useful branch to learn about.
Absolutely. And it's funny you mentioned, because you put these constraints in place, you have this fundamental design of a language, and it's interesting how things trickle down. So, like the ability to do expression-based, being expression-based brings in all this wealth, the composition, the ability to do all these things that, amount to such a powerful language, in its entirety. And it's interesting because you mentioned that, ML and SQL, so they are both expression-based or expression-orientated languages. And the ability, this trait, why then is this trait so useful?
Yeah, because composition is the fundamental tool for building bigger things. And I always use the Lego analogy. You make big pieces of Lego from a bunch of small pieces of Lego. And the bigger pieces of Lego can also be added on because they're all designed to be added onto. Just like another more program example is like all the Unix utilities. They're designed to be input and output. When you pipe an output from one thing into the input of the next thing using pipes, they're designed to be components. And this is a really powerful way of constructing large systems. Is you have little components, each one is designed to do one thing well, and you glue them together into bigger components. And the thing about functional programming is it really, really forces you to use that approach. You don't really have any other choice. With object-oriented programming, there are other ways of making programs, and the classic one is you build these objects, and the problem with it's very easy to make these massive objects, these kind of God objects that have thousands of methods, or that you have this web of objects which all talk to each other, but it's very hard to disentangle them because there's kind of circular references between them, and there's inheritance and stuff. It's not always very clear what's going on in an object-oriented programming. It's not just, so even though you've got encapsulation at the micro level, you have a lot of tangling up at the macro level. But with a functional language, it's composition all the way down, all the way up. It's exactly the same technique. You just glue the functions together. And because the data is immutable, and because everything's got an input and everything's got an output, the composition works at all levels in the program, from the very smallest level all the way up to the top level.
And then one of the others is the symbolic paradigm. Just wondering, maybe you could touch upon what actually then is the symbolic paradigm.
Well, it's basically Lisp. And there are a few other languages like that, but the idea is that you're working, that the data and the code are sort of the same thing. So you're working with symbols. You're not, like C is, everything's an int, or everything's a byte in C. Everything is a word on the machine. In Lisp, everything's a symbol. So it's all about how you interpret the symbol. Do you interpret it as an integer, or do you interpret it as a symbol which you can, do other things with? And this fact that you can mix and match between the different ways of interpreting the things, the atoms in Lisp, that's what they call them, is part of the power. So you can have the same piece of code that actually does something, but that you can then treat that same piece of code as data.
You could be rewriting the program in the same manner as you would be, treating, as you say, treat it as data, and you can rewrite the program. And it brings macro programming to this whole new level. I think people think of the C macros, and they think of that kind of, this is completely different because of the fundamentals in the language using S expressions and things. It really does, blend so well.
There's no, just sort of like Smalltalk and other things. There is no syntax really. Everything's just an S expression. So you don't have if then statements, and you don't have for loops, and none of that. The language doesn't have any of that stuff. So there's a very, very simple set of primitives, and the entire language is built out of that.
And it's funny because, again, Alice Perlis has another, I think this is a bit more tongue-in-cheek, of Lisp programmers know the value everything and the cost of nothing.
By the way, anyone who's interested, if you go and search for Alan Perlis epigrams, you'll find a whole bunch of really good ones. His stuff is very good. He was making a thing on that. There's this classic thing about people who know the price of everything and the value, the price of everything and the value of nothing, especially like economists or something. And so he's making a reversal. They know the value of everything and the cost of nothing, because in those days, I think he's just talking about the Lisp being very slow compared with an imperative language like ALGOL.
It takes its these languages, like the functional languages as well, because the fundamentals. Because you're on these abstraction levels, you need the fundamentals down and things underneath it to make them. The immutability can be a very costly thing. With memory and stuff, keeping everything in, it could be like, wow, how are we going to do this? But it's making the programmer's life easier. But the underlying implementations obviously need to be more complex.
Exactly. I mean, you need to have garbage collection, for example, and Lisp had garbage collection, and it's garbage collection back in the 60s was pretty slow, and now we have very fast garbage collection. In fact, the latest garbage collectors are probably more efficient than what a human can do. So it just takes a while for this stuff to sort of become popular. Same with functional programming. Used to be very slow, but it can be faster now, especially with machines, CPUs that have pipelines. You can do parallel stuff on them and stuff. And yes, a lot of the stuff. I mean, ironically, the functional programming, even with all the extra heavyweight, it's most of the performance, I think, is just this code that kind of gets in the way of what you want to do. So there's a classic thing. If you look, someone did a thing of a Ruby on Rails app. And, you send a request in, and how many methods and how many objects does it have to go through to actually do something? And it's like a couple of hundred easily. And it's like, do you really need to go through that much stuff to get something done? So you can still be high level, but you can also be more explicit and not wrap everything in objects and still get stuff done, So you don't have to sacrifice abstraction in order to be something which is more more close to the problem domain.
Absolutely. And it's interesting because garbage collection is one of those that is very interesting field, to be honest. It's one of those things that's kind of often kind of overlooked, but is a very interesting field, like how languages do garbage collection. I highly recommend people check it out.
Yeah, garbage collection, I mean, I think all languages should have garbage collection unless you're doing real-time systems or something, but it's garbage collection is definitely a very interesting topic, and it's super powerful. I mean, in general, you can actually do, like I say, a good garbage collection can be better than what a human can do. So
definitely. And in the talk, you actually touch upon a paper, "Worse is Better," in regards to this. It would be really interesting. Maybe just, would you mind expanding upon that and actually what the paper discusses and kind of your thoughts on Lisp as a language?
Well, this is written by Richard Gabriel back in I guess it was the early 90s. I'm not sure. He was a big Lisp guy, and he was kind of disappointed that Lisp basically lost the battle and that C kind of took over. And you could say the same thing about Smalltalk losing out to Java or something. And he's like, why? Why is Lisp is so obviously better than C in every way? And why did people prefer C? And he wrote a very interesting essay, which is that what people in C cared about was simplicity. And they cared about simplicity of implementation. And if the person who had to work with C had to do all this stuff to get it work, that's their problem. The Lisp people and the Smalltalk people wanted something to be kind of beautiful and complete. And if it had to be complex, you could hide the complexity behind the interface. But, the important thing was to give the end user a nice, beautiful, simple interface that would be everything they wanted. And what's interesting about that is that because the C style of programming meant that you couldn't, you needed a lot of help to get stuff work, it created a whole kind of ecosystem of people writing C manuals and C training and C third-party libraries and da-da-da-da. And if you have a system which is like perfect, there is no ecosystem. There's nobody. It doesn't need to be improved because it's perfect. Nobody writes. Nobody helps out. There's no. And obviously it's not 100% perfect. But the idea is that there's a whole community of people in C learning C who help each other try and figure out how to do it. And these people have a vested interest in making that ecosystem successful. And so it's not a surprise that, for example, the open source. It was very big in C languages, C and C++, very big on open source. Lisp open source and Smalltalk open source never really took off. There is obviously open source, but they're just much more closed systems because they're designed. People put a lot of effort into designing them. So it's just fascinating. And I mean, he was absolutely right, and it's still true today, where systems. You can see it with PHP taking off. You can see it with MongoDB being more successful than a nice, beautiful system that doesn't have problems. Because with MongoDB, a lot of people started using it. It was really easy to get started. They had all sorts of problems, but then once they had an interest in solving those problems, and a whole industry grew up around fixing those problems.
It's so interesting. It's more of a psychological thing, isn't it? It's more of a kind of human need thing as well. And it's because I mean, you can see it, in other things in life, like Betamax versus VHS and all these other HD DVD versus Blu-ray, whatever side you're on and stuff, and whatever wins out, or it really is kind of interesting what people take sides to. And then if more people invest in, if something's broken and they're likely to help fix it, then you stop, more people flock to it, and then it becomes this bigger herd. Yeah,
it's very interesting, and that's why he wrote it. Here's the idea that something which is worse is, from a kind of a technological point of view, it's worse. Why does that succeed over something which is obviously technically better? And that's one of his frustrations. But it was a very insightful essay.
No, definitely, absolutely. I'll put it in the show notes. And what are your opinions on Lisp? Are you a fan of Lisp?
I actually have never used Lisp that much myself. I was, when I, like I say,
you're a small talker.
Yeah. So this is like the great rival of Smalltalk. I think one of the things about, I actually have a little blog post about this, about languages which are, it's a little bit like the worse is better. Languages like Lisp and Smalltalk are what I call solipsistic languages, where they live in their own little universe, and which is great if you live in that universe, but they don't really, make an effort to communicate outside of that universe. And then some languages are, introvert languages, and some are extrovert languages. So extrovert languages like to do I/O, and introvert languages don't like to do I/O. And an extrovert language, you can tell an extrovert language because on the very first page of the user manual or the textbook is like "Hello World," writing to a file.
That's it. Print out to the screen. Yeah, that's it.
If it's an introvert language which really doesn't like doing I/O, "Hello World," like in Haskell, "Hello World's" like chapter 7 of a textbook. Just because it's not the most important thing about the language, and so I think Lisp is a language that definitely changes the way you think. But it's interesting that Clojure has really. The classical Lisp people, the kind of serious Lisp people, don't really like Clojure because doesn't do things properly. But what it has done is it's really focused on integrating with the outside world. It runs on a JVM or also .NET. It spends a lot of time being compatible with other libraries. It's designed to doing websites and stuff. Rich Hickey spent a lot of time thinking about how to make a much more usable Lisp that would fit into the modern world, and I think he succeeded really well. So it's one of those. Clojure is a language I'd be very interested in learning. It seems to be a very well-designed language, but I haven't had a chance to look at it yet.
Really, really interesting. And another, actually, moving back to the functional world a little bit, with the ML, like Haskell came from a different school.
Yeah, well, the ML was an imperative language. Instead, it had mutable state, and it wasn't designed to be a pure functional language. Now, Miranda and then the Haskell, which descended from that, were designed to be pure. They're designed to be what we'd say lazy, meaning that the answers aren't evaluated straight away. The answers are only evaluated sort of when you need them, and that creates a whole different style of programming. Very, very different way of thinking. And so, I think obviously ML was a big influence on Miranda, but I'm not sure exactly what the history is, but it's definitely now would be considered sort of different branch of the functional world. I think there's the ML family, and then there's the sort of Haskell Miranda family. And there's other ones. And what's interesting is also is academic stuff sort of trickling down. People complain about Haskell being very academic. But most of the programming paradigms that we use started off as academic ideas. I mean, relational database was an academic thing originally. ML was designed for a theorem prover. So anyone who uses LINQ, anyone who uses lambdas, they're using academic concepts which have been gradually migrated their way into mainstream programming. So, it's true that, not necessarily that you can use the academic stuff straight away, but I wouldn't also put down the academic side of things because it's a very important influence on programming.
Absolutely. And finally, the other paradigm that you touch upon is the stack-based concatenative programming.
Yeah, well, that's basically Forth, and there's modern versions of Forth, like there's one called Factor, and there's a couple of other ones. It's just another language which is a mind-blowing. Like I say, we're fish in water. We think that the water is. We're not even aware that imperative programming. We live and breathe imperative programming. We think that everything that's the only possible way of doing things, and Forth is a completely different way of doing it. It was designed as a low-level language. I believe it was for doing telescopes, and it runs on bare metal. It's still used in satellites and stuff today. So it's very powerful. You can use, it uses directly to the CPU, but it's not an imperative language in the way that C is. It's a completely different style of programming. You basically put stuff on the stack, and everything you either put stuff on or you take stuff off, and that's it. That's the entire language right there. But again, you program in a completely different way as a result of thinking that way. They program in what they call words, and it's just a bunch of instructions. It's actually a composition, another way of building bigger things from smaller things. You just compose a bunch of words together, give it a name, and that's another word, and then you compose those words together and give that a name, and that's a bigger thing. So that's how you do Forth style programming. But it's, again, it's not. I wouldn't say it's super useful for mainstream programming. Again, it's quite useful if you're doing microcontrollers and stuff. But it's just a different way of thinking about programming. I think it's worth learning a language like that because it helps you get your head out of the water and learn a different way of thinking.
Well, it definitely has the Galaxy Brain seal of approval. Absolutely. I would be really interested to know kind of your opinion on the concept of a general purpose programming language. I think, chucking languages into this general purpose just list of like languages that are general purpose that can be used for anything. What do you feel around that idea of a programming language being just general purpose?
Yeah, I think it's certainly true that you want to. Like a language like C# or Java, it's very general. You can do pretty much anything with it. And I don't have a problem with that because it's not just the language. What makes something successful is not just the programming language, it's the ecosystem that goes around with it. It's the fact that people have the experience with it. There's the libraries that go with it, and when you're doing the DevOps and the deployments and all this stuff, there's a whole, ecosystem that goes around with it. So once you're in the Java ecosystem, it's nice to stay there because you've got a lot of knowledge that otherwise you'd have to throw away. The way that Forth works doesn't fit in with that, and the way that Haskell works doesn't fit in.
Trying to give that to someone to deploy and be like, "Hey, work out this stack, please."
Yeah, exactly. So, I can sympathize with just having one way of doing it, and especially in a big company, it's nice if everyone's pretty much doing the same thing and everyone can look at each other's code and figure out what's going on. So, yeah, it is useful. I think what the definition of a general purpose language is changing. It used to be that C was a general purpose language, and then what we think is standard now is changing. So garbage collection is now considered standard. And now in the last 10 years or so, the functional programming stuff is now coming in. Having a Lambda way of doing Lambdas is now sort of becoming standard. Having link style thing or stream style thing, MapReduce or something. And I think that will continue. And I think what will become standard will be things like immutability by default, non-nullability by default. I would think that some types, union types, will work their way into languages. Will have exhaustive pattern matching. All these kinds of things. You can see them now coming down the pipeline, and I think in 10 years that will be considered standard. I think some of these things are going to be quite hard to retrofit into languages because things like non-nullability and immutability by default, that's really hard to retrofit. We'll have to see how that goes, but I do think that what we consider standard will be changing over the next 10 years.
All the current popular languages have a very C-like syntax, and one of the things you emphasize in the talk is the fact that there isn't a world out there that is not like this. Statements don't have to be statements; they can be expressions, and every line doesn't have to end with a semicolon. Why do you think these languages and this syntax has kind of stayed around and become so popular, and kind of it's just the norm? People are very, every language. If I'm going from JavaScript to C# to C, all of these languages have this kind of style.
That's a good question, because it didn't used to be true. Even back in the 80s and 90s, a lot of languages, not all languages had the curly brace. You had Pascal, you had Visual, Basic, you had Smalltalk. Yeah, I mean, a lot of languages which are popular didn't have that. I personally don't like the curly brace thing in general, and I think it's kind of weird that you have something like Reason ML, which is a curly brace wrapper on top of a camel. And it's just because people are scared of looking at a language which doesn't have curly braces, which is kind of shocking to me. I mean, we're programmers. We're supposed to be open to new ideas. And I've heard people say, I literally can't read a language which doesn't have curly braces. It's like, I mean, I can understand you say, well, I don't prefer it, or whatever, but literally I can't read a language that doesn't have that. That's not good. And syntax is the least of it. I mean, the way that they work behind the scenes, the semantics of language is completely different. So JavaScript has very different semantics from Java, even though they might look identical. And that's one of the problems, is that you see it's got the same loop, it's got the same curly braces, it must work the same behind the scenes, and it doesn't. And so you have to learn that stuff anyway. So the syntax is really the tiniest part of a language, but it's the first thing you see, and so people get very upset if they see something they don't like. But I have to say, I think that's a lack of breadth in people's educations. I just think it's sad that people. I mean, I probably programmed in 20 different languages over my career, and it's like, you show me a language with some weird syntax, like S expressions or something, say, yeah, okay, I mean, I don't understand it now, but I'm sure, I trust. The thing is that I trust people I respect. If someone says, S expressions might be hard to get used to, but give it a couple of weeks and you'll get used to it and it's fine, then I will trust those people, and I will say, okay, I believe you. It looks weird to me, but I believe you when you say that it's worth it, and I will make the effort. Because I think that at least most of these things are really superficial. And
it's so funny, though, isn't it? Because it is superficial, and it's completely by the by of what the language is. And as you say, familiarity really is a curse of it, because we then assume something that is definitely not the case in some languages. Just because they're using, the same syntax doesn't mean they'll use it in the same way.
A good example is JavaScript, which is really a prototype language. The original version of JavaScript was based on Self, the Self language, which in turn was a kind of prototype version of Smalltalk.
Like IO.
Yeah. And so people don't understand prototype-based languages, and all sorts of stuff happens in JavaScript, which is kind of weird. And so they eventually
that's why they had to put the U in,
didn't
they?
And then they put classes in. So it's like, well, people don't like prototypes. Let's make it make an object-oriented language so it looks more like C or C++ or Java, whatever. It's like, that's an example of the pressure, people really not understanding the language because they're deceived by the syntax.
Well, the new syntax, the complexities around the new syntax and what new actually does under the hood, because it was included like that because of like similarities to Java and C# and whatnot, or Java probably at the time, really. And the fact that it's fundamentally different under the hood, but because of the familiarity, people get very confused by it. And it's not right. You should have it completely different then. But people wouldn't use it because it looked too different. It's a curse, isn't it?
If JavaScript looked more like Lisp, it would probably be a more accurate understanding of how people, how it should be used. But then, people wouldn't like it because it looked too weird.
It is so fun. Yeah, it's strange. And like year six, as we say with classes, it just completely changed. You know, it's completely, it's this level of abstraction on top of something that fundamentally will not change because, you know, the fundamental language is a prototypical language under the hood, but people want to use it in a certain way.
And the same thing with reasoned ML. I mean, I'm not that familiar with it, but it must be a bit disconcerting if you're thinking it's a C-type language and then all of a sudden it has these semantics from an ML-type language. But on the hand, it does work because I guess people are willing to try it because it looks familiar. There's just something, I'm always surprised at developers who are so conservative.
Could it be a more corporate thing, a business-orientated kind of approach where I can probably get this into the stack because it looks like it, even though like people won't spend enough time to understand that this is subtly different, but because it looks like it, it's more likely.
No, I've seen this for people just learning on their own time, learning a new language. They are I've seen, it's surprising to me how many people are reluctant to learn a language that doesn't have curly brace syntax. And these are, you know, supposedly we're developers who are willing to learn new technologies. And I am very surprised. And I think that's actually new because I think it's a self-reinforcing thing because you learn JavaScript, you learn Java, you learn C#. All these languages have the same syntax. And you're not exposed to any other languages which have different syntaxes. And back in the 70s or the 80s or even the early 90s, before this kind of syntax took over, if you were a decent programmer, you would have been exposed to 4 or 5 different types of syntax. You know, you would know a little bit of Fortran, a little bit of BASIC, a little bit of Pascal, whatever, and they'd all be different. And so having a different syntax wouldn't scare you off because you say, like, okay, it's just a different way of doing stuff.
Do you think it stunts the growth, the development of like the languages and like the language ecospace because of this kind of, now we've reached this point where languages that are used, very popular languages, are all very samey, and you obviously have these niches, you know, of people who are, you know, developing and they're very interesting different niches, but trying to bring it into the mainstream, it's very hard to, because this has got this tie now with this language syntax that isn't going to change.
Yeah, I don't know. I mean, it is funny. I do think the syntax is like, people make jokes about COBOL, you know, but this is the COBOL of programming language syntax. It's the curly braces. It's a coincidence. It's almost like QWERTY keyboards. You know, a lot of developers say, "Oh, QWERTY keyboards are so inefficient. I'm going to be they spend a lot of time setting up a different kind of keyboard map." Meanwhile, for the program language, they'll pick a curly brace language because I'm just saying, it's just funny because people spend a lot of time optimizing other aspects of their life. But, you know, I mean, like a language, I mean, one of the reasons I like white space languages is they literally take up a lot less space on the screen. So you can see like twice as much code on your screen. And I like languages with type inference, so I don't have to type as much, you know. And these are all absolutely good things that, you know, I think every language should have. It is funny to me that people were so resistant to that.
It's a self-fulfilling prophecy though, isn't it? And the thing is like, I think maybe at schools and stuff, universities and people learning languages, the languages that they're going to be learning are all like this. So, and the less time they'll spend looking at other languages, and as you say, like maybe in the 70s, 80s and 90s, when things weren't flushed out as much, you had to use different languages and you had far more interest in other languages. Now that this is the dominant winner, it kind of just stays the same, which is very sad.
It is sad. I mean, I hope that ML languages, I hope that F# and OCaml and Haskell will take off and introduce people to a different way of thinking. I think they right now they have the most potential.
You're doing amazing work in that field with the education and teaching you're doing. So you're definitely doing your piece for it.
Yeah, I'm trying anyway. Yeah.
Oh, awesome. Well, say, Scott, thank you so much, man, for coming on again. I think I've definitely spent about a good hour of your Bank Holiday Monday chatting about all this stuff, but it's always so much fun talking to you about all these interesting topics.
I'm just saying, it's my pleasure. I love this stuff.
It'd be really interesting. I mean, I don't know whether you can spill it, but the book, you're saying you're writing a new book. Have you got any ideas of what this is going to be on, or do you want to keep that under wraps?
No, it's a book that I started like 5 years ago, and I haven't finished, which is it's called Understanding Functional Programming, and it's basically all these talks that I do about thinking about composition and railway-oriented programming and all this stuff. I just think I could turn that into a book, which is not language specific. It's really how do you think about functional programming.
That is going to be very apt and very relatable to a lot of it. I can't wait for it. Are you doing it for Prag Prog again?
No, I haven't decided yet. I'll see. I might self-publish it. I don't know.
That's so good, dude. Well, say audience, it's been another great episode, and we'll speak to you again next week. Goodbye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.